In this video, I'm going to show you how to graph an equation into variables by plotting points. So we're going to pick values for x and y and solve for the other variable. And by doing so, we're going to figure out a bunch of points and graph the equation. So let's start with the intercepts. So let's replace x equals 0 into the equation. So when x is equal to 0, we get the following equation for y, and solving it, we get negative 5. So at 0, y is equal to negative 5. Let's introduce the units here. Let's make half of the square 1. So when x is equal to 0, y is equal to negative 5. 1, 2, 3, 4, negative 5. So here's the point on the graph. When x equals to 1, then equation is for y looks like this, and solving it for y gives us negative 7. So at 1, y is negative 7. So what happens when x equals 2? Then the equation for y is this, and y is negative 13. So what do we observe here? As x gets larger, the output decreases. However, when x equals 3, we have the following equation for y that leads to a contradiction, meaning there is no such value of y. But the pattern that we observed suggests that the output gets smaller and smaller. So that's a sign of a vertical asymptote. So the graph of this function will approach negative, it will go down as x getting closer and closer to 3. So what happens when x is equal to negative 1? At negative 1, we have the following equation. So y is equal to negative 4. And that gives us an idea for the graph. The graph looks like this on this interval. So what happens to the right side of 3? So what happens when x is equal to 4? If x is equal to 4, then y plus 1 is equal to 12, y is equal to 11. So 1, 2, 3, 4, 6, 8, 10, 11. When x equals to 5, we have this equation, and y equals to 5. So the pattern on the right side of the asymptote will be like this. Now, we can continue with picking x values, but we can do the same type of analysis with y values. So what happens when y is equal to negative 1? Or let's find out what happens first when y is equal to 0. So when y is equal to 0, so let me this. So when y equals to 0, we have the following equation. So x minus 3 equals to 12, so x equals 15. So when y is 0, x is 15. So the graph goes from here to here. What happens when y is equal to negative 2? When y equals negative 2, we have the following equation. So x is equal to negative 9. So we have this point. So negative 9, negative 2 is this right here. So the graph looks like this. So what happens when y is equal to negative 1? When y is equal to negative 1, we have this equation that leads to a contradiction, meaning there is no such values of x. So this is not the first time we see such outcome. So we conclude that we have an asymptote at x equals 1. And once we learn that we have an asymptote, we can continue the graph far to the right and far to the left. So the graph will approach that asymptote. So this is how we graph this function by just plotting points. So of course, graphing it analytically is better and takes less time.